our role, and our role is to prepare for the future. Our role is to prepare for the future by producing master learners. That's what we produce. We don't produce college graduates. That's what they used to be called. We don't produce engineers per se, although we produce lots of those, or social scientists, or whatever it is that we're producing. We produce master learners. We produce master learners that we hope can have the opportunity to engage in the economic success of the United States, the political success of the United States, the military success of the United States. All of those things are on our agenda. All of those things are on our mind. And so I'm going to go back and tell you just in a second how we do that, because we think the old models, the old style universities, the old way that we've been organized, the old way that we've taught, the algorithms that we use in terms of the way that we construct our knowledge enterprise, they're done. There's very little utility left in any of them. And we've been working for over a decade now to completely restructure the very idea of a teaching, learning, and discovery institution. Now, before I walk through that, let me say that the way that we conceptualize this is quite challenging, because we're surrounded by, and I know there's none of this in the Army, we're surrounded by individuals who believe that their job is to protect the way things are, to protect the status quo. So we're out a bit kind of as a university pariah right now. We say we're not educating a diverse enough student body. We're not educating people who are capable of learning fast enough. The algorithms that we're putting into our master learners are too few in number, too limited in quantity, and too slow in adaptation. So we understand all of those things. Now, if you want to change all of those things, you have to rethink things. So we've rethought ourselves now. We sometimes refer to ourselves as a complex adaptive knowledge enterprise, a complex adaptive learning system. We must have the capability of addressing complexity, embracing complexity, racing to complexity. It really is the case when somebody says, make it simple, stupid, they're the stupid one. I don't know what it is that's simple these days. Not very much is simple. Our missions are not simple. Your mission is not simple. The world is not simple. 7.5 billion people growing rapidly to 10 billion people. Cities, as we've heard, Baghdad, which some of you were a part of the war in Iraq, it's not even a large city. It's like 35th or 36th on the list of present cities. It's probably less complex than many of the cities that are evolving on many, many different dimensions. And I'm only using social and cultural dimensions here. So let me back up a little bit and say that it is time for all of us to find ways to make our organizations complex, adaptive, high-speed, high-change, complex adaptive systems, complex adaptive learning systems. And I'll walk through a little bit about what we've been able to do here at this university. A few years ago, I had the pleasure of being invited by the Army Chief of Staff to visit with some of the strategic leadership training groups that he had initiated. And as a part of that, I wrote an article with another person called "The Need for the Strategic Corporal." I don't think anybody read it, but let me tell you, let me tell you what it basically said. What it basically said was that as we move forward, the single most important thing that we're going to need in the military, on the ground, is the most intelligent, most capable, most adaptive, highest learning possibility that we can put into a person, all the way down to on-the-ground soldiers, the strategic corporal, who's involved in a situation that requires an ability to understand cultural diversity, who's involved in a situation where you must understand biological threats, chemical threats, physical threats, everything that you can imagine. Not because they're the commander, back to the notion of the role of command. I'm not diminishing the role of command. I'm suggesting that one of the things that we've got to focus on is that at the end of the day, the decision makers are at all levels of the organization. As complexity increases, if they can't embrace that complexity, doesn't make any difference what you want to do, we're not going to succeed. Doesn't make any difference how many robots we have, how many machines we have, how many tools we have. At the end of the day, It is person to person, one way or another, in either combat or humanitarian response. Either way, person to person. And those things, by the way, are all correlated as we go forward. Combat, humanitarian, results, back and forth, this, that. You're all aware of that, more aware of that than I am. So this mad scientist meeting, it's a perfect name. Can we throw the normal algorithms, the normal parameters to the wall, pin them up against the wall, and actually push to some extent, at least in this kind of forum, in this kind of structure, can we push the reset button? So you'll say, yeah, you're just running these big colleges here, and so what do you know? Okay, here's what we've done. So I'll just pick one example. So people say that we need new kinds of engineers, we need more diversity in our engineers, we need our engineers to think more broadly, we need a lot more of them, we want them to come from every walk of life, we want more women, more minorities, we want them not just to be just, we want them so that we can have the breadth of talent, the breadth of ideas, the breadth of solutions. In 2005 and 2006, the National Academy of Engineering, the most elite group of engineers in our country, said it's time for engineering schools to change. The world is changing. It's time to focus the engineering schools on the grand challenges of the future: urbanization, issues related to sustainability, issues related to biothreats and biohazards, and opportunities related to renewable energy. So it's both threat and opportunity. And could we build engineering schools around the idea of actually using threat and opportunity and excitement as a way to change the way that we produce and engineer? So the president of the National Academy of Engineering came out, Chuck Vest. He was the former president of MIT, a friend of mine. He served for many years with me on the board of InQtel, which is an intelligence community, defense community asset that's being used to rapidly find and deploy advanced technologies into national defense and national security. I've been the chairman of that board since 2006. So Chuck was on that board with me. I knew him very well. He came out here as the president of the National Academy of Engineering, and he outlined what we needed to do. And he went to many other engineering schools around the country. How many changed their structures? One. We eliminated all 11 engineering departments. We created 5 Grand Challenge engineering schools. We found a series of technology partners, about 140 partners in the ed tech business. We built a learning platform, injected it not only into our engineering schools, we now call them engineering schools, but into the rest of the university. We had 8,500 students in engineering then in 2008. It took us 2 years to make the design transformation, to change the algorithm, to fight our way through all the laggard thinkers who thought that the way the world should be is the way that they were educated. And like some of you in your jobs, they couldn't kill me off. So I'm still here. They were surprised. And so then 2 years to do that, and then so that's 2008. Something else was going along in 2008. A little recession came along, small disruption. We lost 61% of our public support per student. Who cares? You still have to plow ahead. You have to adapt. You have to adjust. You have to move forward. 8 years later, so in 2008, we had 8,500 engineering students and a 68% freshman retention rate. Now, we found when we injected technology, changed our pedagogy, changed our structure, that this notion that you can't get people to learn math, or you can't do this, or you can't do that, that's all false. That you can't produce a master learner as an engineer, false, false, false. So now 8 years later, 17,000 engineering students, twice as many, 90% freshman retention rate, 3 times the diversity, 2.5 times the number of graduates, and several times the amount of research, all being done by the same faculty in a different structure with a different algorithm. Now, we've done what I'm talking about in engineering in 16 other places in this university. A school of Earth and Space Exploration, changing that algorithm. A school of sustainability, changing that algorithm. A new school for the future of innovation and society, thinking about how you can build technologies for the future to achieve this complexity of outcomes that you're looking for. So let me come back to complexity. The level of preparation of the American universities and the American military and the Army specifically for what lies ahead is somewhere on a scale of 0 to 100. And I'm sorry to tell you this, but I'm throwing ourselves into the pot with you. on a scale of 0 to 100 is somewhere around a 10. And that doesn't mean that we haven't been performing in the past at 90, 95, 98, 97. And the reason that I give the number as so low is that we're about to enter something in the evolution of humanity that we've never encountered before. Billions of people from thousands and thousands of ethnic groups compressed together in 150 to 180 places, these large megacities. With then something else that's beginning to happen, and you'll hear a little bit about this from Professor Post later, the final understanding that we evolve in a very funny way. It's not just us. The very biology of our species is altering. The co-evolution of other species on the planet is evolving with us. And I'm talking about things that we can't see, microorganisms and bacteria and everything and diseases and viruses and all these things that have never encountered what we're producing as the physical, biological shape of the planet. We've never had ubiquitous information. We've never had the ability for hate messaging to be cued into individuals' ways of thinking. So, by the way, if you don't know, we're an all-in defense university. Thousands of people at this institution are doing something to advance national defense. We're training future officers. We're the largest producer of nurses for the Army. Whatever it is, the list is pages long of the things that we're doing. One project that we have under the Minerva program coming out of the Secretary of Defense's office is a project where we're looking at functional magnetic resonance imaging outcomes of hate messages from Islamic fundamentalists going into human beings so that we can determine whether or not human beings respond differently to those messages by looking at the actual functionality of their brains. Guess what? It triggers an inner core, deep, antecedent, old evolutionary characteristic. It's a messaging that triggers, based on our research to date, triggers a certain kind of biological response. Well, now that we have the means to send out such messaging, now that we have the means to communicate at scale, now that we have the means for all of this complexity, how do we manage this complexity? How do we be responsive in engagement to conflict, to natural disasters, to biological and chemical disasters? How do we design for complexity? And so this mad scientist effort is the first step. You question the present design. It doesn't mean you throw the baby out with the bathwater. We haven't thrown out all of the past. We haven't thrown out our genetic code that goes all the way back to the Greeks and the Greek academies, sitting with Plato and others, sitting around dreaming about how to produce knowledge. We haven't eliminated that as a part of our genetic background, just like the Army won't eliminate the lessons learned in fighting the American Civil War, and we heard about Fort Leavenworth in the 1880s, and learning how to think and learning how to adapt to the complexities of dealing with the fights in the Indian Wars and insurgencies and all the other things. That's the cumulative knowledge of the Army. And all of that is fantastically important and valuable. But I think that what I would argue that what we need to do in terms of the designs, and I haven't thought this through enough, although I could, how many parameters does the Army have in its algorithm? And what I would suggest is those at the core, the hardened core of the Army parameters, are solid. Solid. Leadership, duty, training, all the things that you guys have been through. How many parameters do we not have? How much awareness do we not have? How do we think through what the algorithm should be for decision making? Because at the end of the day, that's what it's about. It's about decision making. And so from my perspective, and I hope that we can be helpful on this, you have to go back to, as we heard earlier, to people production, master learner production, idea production, and start thinking through this notion of how to confront the complexities that we, sadly, those of us in the room, most of us look like somewhere between 20 and 30 years old, right? Let me back up a little bit. So here's something we know in the business that we're in. So we'll get 12,000 freshmen this year coming in from high schools directly, 12,000 full-time freshmen. We'll get 11,000 transfer students from community colleges coming into ASU, 23,000 new undergraduates. They'll come from 140 different countries, all 50 states. They're completely representative of the entirety of the socioeconomic diversity of the United States. 20% of our undergraduates come from families at or below the poverty level. So we are dealing with our society, and here's something that we know. The human beings that are arriving to us now, they're not the same species as you. They're Homo sapien sapien.net. I mean this in all seriousness. They are not the same species as you or me. They have never lived without access to some kind of a virtual supercomputer attached to their body. We have to figure out what that Homo sapien sapien.net is. How does that person learn? How can that person be influenced? How can you communicate with that person? And so the conflicts of the future are all going to have to then realize that there is a huge transformation in human evolution. People never had any of this before. Never existed. And now it exists. So now you have tens of millions of people living in Islamabad, with half of those people having direct access to supercomputer capabilities, and everyone else being one person removed from that. What is that? So the central theme of the Mad Scientist effort, I hope, will be to figure out how to produce the right set of expanded parameters to address complexity. So one of the things that we've done with the expansion of the parameters to address our own complexity is the unbelievable asset that we found in educational technologies. We have 150 partnerships. We've built a learning platform that's unparalleled. We launched a program in August just to offer a few courses to some folks. On a global basis, we had 192 countries respond, over 120,000 learners for the first couple courses that we put out. We had 12-year-olds in Peru complete college astronomy courses for credit. I don't know what that means. It means something. I had a meeting yesterday with Bill Gates in San Diego as a part of the ASU GSV Innovation Conference on Educational Technology that we had 3,600 people attend yesterday. And I was walking through with Mr. Gates the fourth realm that we're presently operating in, which is education through exploration through game-based learning. Or just imagine this at the end of the game, and we're building this game. At the end of the game, you don't take a single test. You don't take a single course. You don't have a single lecturer. And at the end of the game that you play, you'll be able to pass any college entrance exam, or what we call Cambridge A-level exams. Anyone that completes the game, boy, girl, doesn't make any difference. Any A-level exam in math, chemistry, physics, or biology. Period. What does that mean for learning? What does that mean for changing the outcomes of the way that people think? What does that mean if that same technology and that same capability is put into nefarious hands and you're not learning math and biology, but you're learning how to deploy genetically activated weapons? And so I can't even begin in the time that we have to walk you through all of the things that we deal with here, but we've had scientists at this institution self-edit their own work. So the thing that they developed with their 22-year-old students that could become viruses of weapons of mass destruction, they decided not to publish those. Imagine that, a bunch of geeky professors and a couple students sitting in a lab, Phoenix. We better not publish that. Somebody's going to use that and kill a lot of people. And so how do we expand even the idea of what is conflict? How do we expand the idea? And you don't want your brain to explode, but you want it to almost explode. And that's why I like this name, Mad Scientists. You need to really stress and push the limits here of your thinking. You must assume that the algorithm that you have for solutions is completely and totally inadequate. And that's really hard for people to do. We went through that. Completely, totally inadequate in our own institution. So, I don't know if I've run out of time or not, but any questions? Somebody said yes. Any comments, questions? So again, we're all in. We're excited about this. We're happy to be a part of all this and look forward to working with you in the future. Thank you.
Not so fast. I think perhaps part of the reason that there were no questions is because some of us are still trying to process everything that you said. Holy cow. I did want to share one thing, though. I'm an old warhorse, a retired soldier.
Yes.
And there are a bunch of our mad scientists are retired soldiers and other services as well. And many people will say to us, thank you for your service. And after today, and listening to what you had to say, the standard for a true appreciation for what the United States military does for the nation, the standard for their appreciation is Arizona State University. So I'd just like another round of applause, please. Now, within the Army, we have a tradition, and it goes back to our Special Forces units would have a token that they would give to other members of the unit. And they were called challenge coins or spirit coins or unit coins. And we actually have one for the mad scientist. It has a brain on a computer chip.
Wow.
And now it comes with certain responsibilities, though.
Yes.
So if another person who is a bearer of this coin
Yes.
challenges you,
Yes.
well, you owe him a drink if you don't have it.
Okay.
And likewise, if you do have it, they owe you a drink. So
Okay. All right.
thank you very much.
Thank you very much. Thank you.
Thank you. Wow, I'm still processing a lot of that. So with that, I'm going to turn over mad scientist to the maddest of our scientists, Dr. Kira Hutchinson.
Good morning, mad scientists. I just have one thing to say. Don't you look audacious. So, Mad Scientists is an initiative to help allow for broader perspective and problem solving. We are about 1 year old, and we are changing the way the Army looks at the future. These fine gentlemen who came before me talked to you about the why this is important. My job in the next 2 minutes is to tell you how you do this. Next slide.